the ones I'm seeing the majority of are 4 and 5. Were there? I did see a couple others. If you have something else, keep your hand up. We'll do 3 as well. So 3, 4, and 5. So we're going to show how we could do those in Desmos. With number 3, there are 2 different ways to do that. I don't know how well this is going to work, but we'll see. So one way, you could put the expression in, but capitalize the x's. And then it'll ask you to add a slider. And when you do that, you can change the value to -3. And it would solve that problem for you. Or you could put the expression in with -3 in parentheses. So either way, the answer to that one would have been 3, and you can write did work in Desmos, use Desmos for your work if you're using one of these methods. Questions on that one? Number 4, if I put in the order pairs, and I looked at the 2 points and counted the slope, this doesn't have a rise, so that would be 0. It doesn't have a run, so that would be 0 over some number, so the slope there would be 0. And again, you can either calculate that by hand, say you use Desmos. Number 5, let's see, you don't need Desmos, but I will show you how you can do it in Desmos. Also, to check yourself. So this one we could just start at -2,4. Use our slope of -2,3, so go up 2 to the left 3, and down 2 to the right 3, as many times as possible. And your line should look something like that. It doesn't matter if the line intercept is a decimal or a fraction. It's not asking for that. You just have to graph the line. If you were double checking this in Desmos, we could put in our equation y equals mx plus b. Add all the sliders. Put in the point -2,4. Change our slope to -2/3. And then change your b value by pressing play or moving this until it goes through that point. And it happens to be a decimal at 2.7. So you could use Desmos to double check yourself. Does my line look accurate? Questions on any of the short fight questions? Okay. So today we're going to continue our inequality notes. This is an advanced topic. So specifically for you guys, the other classes wouldn't have seen it. You can go ahead and write this definition. So compound inequalities are 2 inequalities or more, but we're just dealing with 2, that are joined together with the words and or. inequalities have a tendency to graph apart. I'm going to explain what that means here in a second. So if I were given this example, let's say we already solved it, and we got this, x is less than or equal to -2, or x is greater than 3, you're going to have two graphs on the same graph, and they're going to face away from each other. And you're going to graph both how you would graph them normally. So it doesn't matter which one you start with. I'm going to start with the first one. So this will be closed at -2. It's everything less than or equal to, so that would be going to the left. X is greater than 3 would be at 3, open circle, going to the right. So the inequality notation would be this. But the interval notation, again, we're reading left to right. So starting at the left, where would this start? Negative infinity. And then we're looking at where does that stop? -2. Would that be parenthesis or bracket? Bracket. -2, bracket. Then you're going to write the word or. Where does this start again? 3, parenthesis or bracket? Parenthesis, 3. And then where does that end?
Positive infinity.
Positive infinity. So when we write our interval notation for compound inequalities, we're writing both of them.
How do you know which one's bracket and which one's parentheses for like the -2?
So looking at this, if it's closed, square bracket. If it's open, parentheses.
Okay.
But if it goes to positive or negative infinity, parentheses always.
Okay.
Right? Other questions about that?
So this like if it would have been a -3 would be bracket. Which is -3.
It doesn't matter if it's negative or positive. It depends on if it's closed or open. Alright, so now we're going to solve some of these and graph and find the interval notation. So solving is just like what we were just doing last class, except you're solving these separately. Whatever you do here, you do not do to the other one. Completely two separate inequalities. So for this one, to solve, we would do what? Add 4 to both sides. So x is less than -3. And then for the other one, we would do what? Divide both sides by 2. So that x is greater than or equal to 6. Once you have both of your inequalities in the middle of them, you need the word or. So even if they're off, if you want to put or and draw arrows to it, you need the word or in between them. Then we can graph both. So x is less than -3. Well, that would be open at -3, going to the left. X is greater than or equal to 6, closed at 6, going to the right. And then how would we start that interval notation?
Parentheses negative infinity -3 parentheses.
Yep. And then 4.
Bracket 6 infinity parentheses.
So negative infinity with a parenthesis to -3 parenthesis or square bracket 6 to infinity parenthesis. Most of your ors will look something like this. You may have a mixture of one being a parenthesis, one being a bracket. You may have all brackets. You may have all parentheses in the middle. It depends. Do you have any questions so far? Let's skip to and do solve both of them. How would we solve the first one?
Subtract 9.
Subtract 9. We have 2x is greater than
8.
Thank you. I completely blanked this in. And then divide. So x is greater than 4. For the other one,
Subtract 10.
subtract 10. So we have 5x is less than 0. Keep going. Divide both sides by 5. So that x is less than 0. Bring your or in between them. It does not matter that these are not in the right order right now. If you would like them to be in the right order, you can fix it. Put the one that was faced to the left first, but it doesn't matter. Go ahead and graph them. Graphing matters, the order in which you graph them, the way you graph them, not really the order. What would that interval notation look like?
Parentheses.
Negative infinity, comma, 0, parentheses, or parentheses, 4, comma, infinity.
I didn't do this in two separate columns. Negative infinity, 0, both of those in parentheses, or parentheses 4 to infinity, also in parentheses.
To infinity.
Say that again.
Nothing.
Questions on this? Let's skip down to do 5 now. Okay. For this first one, you could either distribute or divide, but if you divide, your sign is going to change, so just keep that in mind. Which would you rather? Distribute. Okay. So negative 6x minus 3 is less than negative 15. Add 3 to both sides. And divide both sides by negative 6. Now the sign is still changing, but now it's changing later instead of first. And then for the other side to solve that,
Subtract 1.
we have negative x is greater than or equal to 4.
Divide.
5.
Negative 1.
So that I'm going to bring this all the way down. X is less than or equal to negative 4. Okay, go ahead and graph those. And then how would we write that notation? Where does it start?
Negative infinity.
Negative infinity to
Bracket.
negative 4 with a bracket, or parentheses 2 to infinity. So if you only write half of this, you're going to miss points on the test, on the quiz.
So for the interval notation, is it okay if you you just do the 2 comma infinity first before the? Does it matter before there?
It does matter. So it has to be read left to right, least to greatest. Other questions on that one? The only slight difference you might see on the Delta math, so you'll see 2 separate inequalities, you'll solve it, you'll graph it. Most of the time, the graphs will graph apart. Sometimes they will graph on top of each other, but it's just looking for you reading it left to right what would that look like? So when you do the notation, if you need help with that, let me know. Yes.
Would it be like one on top of each other going the same way?
Yeah, so there would be different variations of the compound or where they may be both going in the same direction, going apart, or crossing over each other, and you're really just looking for, from left to right, what is this entire graph saying? But again, if you have questions on that, when we get to that, let me know. So we'll start this, but we won't get into much before we go to lunch. So everything we just did about or inequalities is the opposite for each. You don't graph them separately. You do everything together. So inequalities have a tendency to graph together. So if I were given these two, x is greater than or equal to -6, I'm going to go ahead and graph that one. -6. And then x is less than or equal to 1. You'll see they overlap. Here, you're always looking for where do they overlap. And when you graph this, you really just want one answer. Where do they overlap? From this point to this point.
-6 to 1.
Correct. So when we write our interval notation, we're only going to write from -6 to 1. And they're both equal to, so those would both be brackets. Is this color hard to see?
Oh, it's a fun color.
I always start to use dark colors and then not colors.
Right, so you don't graph the other one?
When you say don't graph the other one, you mean write the other one, these two? No. And when you graph it, it doesn't matter for me if you have all three, but you need to have at least this one. If you want to keep graphing those two to make sure you see where they overlap, that's fine, but you have to have the third one, this point to this point. Okay, really quickly I'm going to write this and then we'll stop. Because they fall between two endpoints, instead of writing it like this, x is greater than or equal to -6 and x is less than or equal to 1, they condense it so that it's -6 is less than or equal to x and less than or equal to 1. So in Delta Math, you may still see two different things, but when you write your answer, you want it like this. We'll talk more about that when we get more. That we're going to rewrite this as a more condensed form. So when we read this, we always have to put less than or equal to, or less than, depending on what the problem is, never greater than. So let's say you solve it and at the end your signs change direction, you have to flip the whole thing and change it back. So let's do some problems. Okay. So with this, we're going to solve everything all at once. So we're trying to get x by itself from the middle. So we can subtract 4 to everything. And then simplify. So when this is already in this format, it'll be as a condensed form when you go to write it.
Do we make it greater than or equal to with the 4 between the 9 because it wasn't?
Oh, no. Okay. That was me adding an extra thing. Thank you. If, like on Delta Math, you may see them separately instead of condensed. So, and if you wanted to separate them and then recon them, then you could also do that. So what you would do is cover up half of it, the last part of it, and write that as is. I'm just going to write this, not solve it. And you would solve that piece, and then cover up the other half, and solve that piece. And at the end, when you get your two things, this would be x is less than 5, and this would be 2 is, not 2, -2, less than or equal to x. And when you put it together, you have to put it least to greatest. The numbers go on the outside, the x goes in the middle. Always less than or equal to. Okay, so let's graph that. Yes.
So just do them separately. You don't have to put order because it's a
Correct. So because these are and, you don't have to put or. You just have to make sure it's indexed. Is all. Okay. This will be the last time that I draw both. After that, I'm just going to draw what we have. So if you would solve this in condensed form, you would start at -2. That would be closed. End at 5. That would be open. And just draw a line that connects them. But if you still wanted to see the other two, or let's say you solved it separately, you could cover up part of it, graph just the middle to everything else. X is less than 5. And then cover up the other part, but read it backwards. X is greater than or equal to -2. Then you could see where those two lines overlap. Again, the arrows part is not necessary for this. You really just need the line where they connect. So then if we're looking at the interval notation from -2 to 5, how would you write that?
Wait, no, are there, like a question with that line that shows like what the two parts. If one's a closed circle and one's an open, does it have to be on that line, or does it have to be like one closed and one open, or can it just be both
That
closed?
depends on the problem. So if they're both equal to, or maybe both aren't equal to, or one is one of each, it depends on the problem. So that part doesn't matter, but it depends on the problem. So we're going to start this at -2. Would that be parentheses or brackets? Bracket. And we would end at 5, parentheses or bracket. So these ones should not have infinity. Even though the other two keep going, we're just looking at where do they overlap. Questions on that? Alright, let's do number 8. How would we solve that? Add 4 to everything. One common mistake I see a lot is that it gets added to one side but not the other, and then the rest of the math gets wrong. Okay, and then
divide by 3.
divide everything by 3. Okay, so if we were graphing that, these would both be closed. Starting at -2, ending at 2. How would we write that interval notation? Bracket. Okay. So these will either be both bracket, both parentheses, or a mixture. Any questions on that one? Okay, let's do number 10. This one is like one we've done before. We could either divide everything by 2 because everything here can be divided by 2, or we could distribute and deal with that. Do you want to divide or distribute? Divide, okay. If you want to distribute, you can still do that. I'm going to divide everything by 2. So again, this only works if everything is divisible by what you're dividing by. So -1 is less than, the 2's cancel here, so x minus 6 is less than or equal to 2. Then just get rid of 6. If we had divided by a -2, all the signs would change. So then it would be flipped. and be greater than. So, for example, I'm just going to make this up really quickly. If I were to divide a negative, and I have positive 1, which is greater than x minus 6, this would be negative. That's the one there. And then you would keep going. 1 greater than minus 6. Greater than 6. And divide everything by negative along one side of this. Now, I added an extra sign in there. This one. Oh, that was negative. I know. But then you would take this whole thing and flip it. Just the lesson. Oh, I didn't change the sign anyway. So that was probably a bad example. But because we ended up flipping it twice. But in a case where you wouldn't flip it twice and only flip it once, if this had just been x instead of x minus 6, we wouldn't have had to leave the negative outside. But then at the end, you would have flipped the whole thing. So if this was like 5 on this side, 8 on this side, we would have flipped the whole thing. But I made a problem and that didn't work. So, what was your question?
Why is not less than or equal to?
This one, it should be. Okay, so let's graph that. Sometimes your line is really short, sometimes it's long.
So you don't have to put like the 2 arrows and then find them.
Not for the and. For the or, yes. For the and, no. Right, how will we write that interval notation?
Parentheses fine with bracket.
8 bracket. So 8, not infinity. Okay. Do we have any questions on how to solve and inequalities? Because now when we go on to the next thing, we're going to be using both and or inequalities. Now we're dealing with absolute value inequalities. So some of this is going to be like our absolute value equations, where we have 2 things and we are solving both. But then the other part is what we were just talking about, our and our ors. So I'm going to give you the general case, and then we'll talk about how to actually solve these. So if we have some greater than or equal to, we are going to drop the absolute value, keep whatever is the same, so whatever the sign is, whatever the number is, keep it the same. But then you have to have 2, and the other one you're going to change the sign, just the direction, not from less than to less than or equal to or vice versa, and make this a negative. And then you're going to graph both and write that interval notation. So this would be flows to the right at 5 and flows to the left at -5. We can do the interval notation, then we'll talk about which type. So interval notation, where would that start? Negative infinity, parenthesis, negative infinity to what point? -5, bracket. And then because these are going away from each other, this is going to be an or. So write or. And then it starts again at 5, bracket, and then ends at infinity. So what's nice about these is they will both be closed or both be open, which means both parentheses or both brackets. So all of your greater than or equal to if you don't have to change the sign, is going to be or. Questions on that before we do the other one?
Why do we have to make it a negative?
So with the absolute value equations, we had to set up two equations because absolute value measures distance, the positive and the negative. Basically the same thing here.
Oh.
So we have to have the positive and the negative version of it. Right, so same thing for this one. Drop the absolute value, keep it the same. Then change the direction of the sign and make it negative. Now, because we know that was an or, this has to be an and. Whether you draw all three or just the where they overlap is up to you. I'll draw all three. So less than or equal to absolute value inequalities are going to be and inequalities. Which means when we write that interval notation, what would it look like?
Bracket, negative 8, 8, bracket, bracket.
So the biggest thing is keeping them straight. And even if you don't memorize that greater than or equal to is or, and vice versa is and, being able to solve it, being able to graph it, and know which type it is.
Just by looking at this line,
Most of the time. So like in this problem, if that were it, yes, you would know it. But if you have to solve and you end up with something that has a negative, maybe not these ones, but maybe somewhere here where the sign is going to change, that may change your whole idea. Okay, write this down. So, absolute value inequalities are really compound inequalities where less than or equal to is and greater than or equal to is or. And then to solve our absolute value inequalities is very much like equations. Isolate the absolute value expression, get everything outside of the absolute value away from it. Create two cases. Once that has happened, keep one method the same, or keep one the same after you drop the absolute value. Then the other one, switch the sign and switch the direction of the sign and switch the sign to a negative. Solve both inequalities and then graph the solution. And write your answer in interval notation. So we are not going to do the first two because they're very similar to the ones we just did, but we will start at 3. So right now, we know that the signs wouldn't change because we're not going to multiply or divide by a negative number. So then greater than we know is 4. So this should be an or. And that's something we could kind of say at the beginning. Right? Isolate the absolute value. There's nothing outside, so check. Drop the absolute value and set up your two cases. One is going to be the same. X minus 1 is greater than 6. The other one, x minus 1 is less than negative 6. Change the direction of the sign, make it negative. Solve both. greater than 7, x is less than negative 5. Because this is or, put or between them. Graph them both.
Why is one equal to -5 and one
Because 1 was negative 6. So you have to change this one to negative. Those should both be open. And then how would we write that interval notation?
negative infinity, -5, parentheses, or 7 infinity, all in parentheses.
Correct. So everything's in parentheses, negative infinity to negative 5, or 7 to infinity, all in parentheses. Do we have any questions on that one before we do 4? This is a less than or equal to, so that's going to be which type? And. So with your and, you could do one of two things. Still set up your two separate things, or you can condense them. I'll show you what that means. So it's already isolated. So if we were creating our two separate cases, that would be x plus 2 is less than or equal to 7. Keep it the same. The other one would be x plus 2 is greater than or equal to negative 7. And what you could do if you wanted it to be already in condensed form is put the least number less than or equal to, put the middle, x plus 2, and then less than or equal to 7. So you could either solve them separately or solve them all together. That is up to you. At the end, though, you still need something that looks like this. Okay, so if we subtract 2, we should have that x is between negative 9 and 5, both closed. And what would that interval notation look like?
-9, 5 in brackets.
Both in brackets. Have any questions on that one? Yes.
So like the numbers in between would be like a solution.
Yeah, so basically all numbers, decimals, fractions, whole numbers between these two to include negative 9 and 5 could be solutions. But if they were not equal to, those wouldn't be included. Alright, going back. Five is like the ones you're, it's similar to the ones you're doing. But I'll let you guys choose which of those you want to see. You've got longer have questions about. 10, 8. I think those three are good. It's so complicated. Thank you. Okay. Alright, for number 3, let's go ahead and isolate it first. So don't ever make the decision of if it's or and until after you've isolated it. To isolate, get rid of the 3 by dividing both sides. This should stay in absolute value bars until it's isolated. Now that it's isolated, I can look at the middle and see that nothing is going to change the sign. So this is going to be greater than or equal to, which is or. Alright, then we can set up our two equations. Drop your absolute value, 2x plus 8 is greater than or equal to 10. And the other one, 2x plus 8 is less than or equal to negative 10. and solve both. You want to put that in the correct order. X is less than or equal to -9, or X is greater than or equal to 2. You could do that. Go ahead and graph both. And how would we write that interval notation?
Negative infinity, comma, -9 brackets, or 1 is brackets, comma, infinity, parentheses.
Oh, yeah, that's what you want to do.
Two divided by 2 is 1.
Oh, I wrote the wrong thing, but it should have been 1. Yes. Yes. I don't know if this thing is going to work, so just go ahead. The internet has been finicky today. Faith, just make sure you work on the self math and come see me tomorrow if you have any questions. Okay, we're next week. Alright, do we have any questions on 7? Okay. Number 8, how would we isolate the absolute value?
Multiply by -2.
Multiply by -2. So when we do that, the sign is going to change direction. So it was an and, but now it's an or. Right. It is now isolated, so go ahead and drop your absolute value, set up your two equations. And solve both. -1, but yeah. And then interval notation is going to look very much like the last one. Negative infinity, -1, bracket, or bracket, 5 to infinity. Any questions on number 8? Let's do 10. Yeah.
It's a negative number.
The negative doesn't determine that, but the closed or open circle does.
And how do I know it's closed or
Look at the symbol. So equal to is closed with this bracket. Okay. Number 10. We need to isolate the absolute value. How would we start that?
multiply?
For a couple different things. If you wanted to get rid of the 1/2, that's fine. You would have to multiply everything. You can do that, but sometimes if the fraction is not like 1/2, 1/3, something like that, you're going to end up with fractions also. You could do that. What else could you do?
Minus 11.
Subtract 11. So either or, either choice is fine. So we would have had to multiply regardless, because at this point we should just be flipping this and multiplying instead of dividing by the fraction. So we have absolute value 4x minus 4 is less than or equal to 8. So this is going to be which type? And. So that means I should be able to write it as a condense. So that would be 8 and negative 8. So you could write the two separate ones and then condense it, or just go straight into negative 8 that's less than or equal to 4x minus 4 that is less than or equal to 8. And then go ahead and solve that. Add 4 to both sides. And divide everything by 4. When you draw your line, start at negative 1, end at 3. How would we write that interval notation?
Rabbit's gonna be from.
Say it again.
Rabbit's gonna be from. Brackets negative 1 and 3 brackets.
Do you have any questions on that? This is like the most you might have to do in a problem. Isolate by subtracting and multiplying or dividing, and then set up your two equations, and then solve, and then graph, and then write the interval notation. Okay. So then, for the remainder of class, you'll be working on one of these things. If you haven't finished the multi-step inequalities or linear inequality word problems that are due on Friday, you can be working on that. The compound and absolute value inequalities dust math is due next week. Should be due next week. I can double check that. You can work on that. You can keep working on practices in the notes, or work on your SQL practice. I don't know how well the internet is acting right now, so try your computer, try the iPad,